Experimental probability is simply what actually has happened in an experiment. The experiment has been done and we're looking at the data afterwards. In the next lesson, we'll look at theoretical probability, which is what should happen. So by definition, experimental probability is the comparison of the number of times the event occurs compared to the total number of trials. So we're going to find the probability of drawing a diamond from a deck of cards. It's like my ink got a little bit scratched. So for the first set, we're going to have 4 trials because it's a comparison of the number of times the event occurred out of the total number of trials. So I'm going to pick 4 cards from this deck. I have an 8 of clubs, a 2 of diamonds, a 2, actually I spoke wrong, that's 2 of hearts, 2 of diamonds, and a 7 of spades. So of those 4 trials, 1 time the desired event occurred. Okay, so now we're going to redo that trial with 10 cards. Put these back in here. So let's see, there's 1 card, 2, 3, which is a diamond. I'm going to put it over here to the side. 4, 5, another diamond. 6, 7, 8, 9, and 10. So out of those 10 trials, 2 times I drew a diamond. So 2 out of 10, which could simplify to 1 over 5. When you compare those 2 experiments, you can see that experimental probability will not always be the same because it depends on the experiment. Here's an example. Tanya made 15 out of 25 shots. What is the experimental probability that she will make a save on the next shot? So we're talking about basketball here. Write as a fraction, decimal, and a percent. So the probability that she gets a save is the comparison of the number of saves to the number of shots attempted. This is based on what has actually happened. So 15 out of 25. 15 saves out of 25 shots. I'm going to simplify that fraction by dividing top and bottom by 5 and get 3 out of 5. Now I also need to write that as a decimal. If you don't know, 3 over 5 is 0.6 on your calculator. Divide the top number by the bottom number, 3 divided by 5, and you get, well, 0.6. And as a percentage, you move that decimal over 2 spots, and that would be 60%. So if you think back to our first lesson on probability, it's a little bit more likely than unlikely, but it's still kind of going down the middle as to if her chances of making that save were based on what the past experiences were. Here's some practice for you. So first you have Cam throwing some darts, and on the second time you have Benita, and she is trying to predict if people are going to eat lunch at the park, and there's 2 parts of that question. Go ahead and pause the video. Keep in mind that ratio, that experimental probability is the number of times that event occurred over the total number of trials. Go ahead and pause the video, try this, and then compare with what I have. Okay, so for the first one, Cam hit the bullseye in darts 8 out of 15 throws. What's the experimental probability that Cam's next throw will hit the bullseye? So we're basing this on past experiments. So he'd hit that 8 out of 15 times. As a decimal, that's 0.53 repeating, or if you wrote that as a percentage, it would be 53.3 repeating percent. B, Benita's been recording the number of people eating lunch at the park. There have been 50 or more people at the park 9 out of 14 days. What is the experimental probability that there will be 50 people during lunch, 50 or more people during lunch on the 15th day? So based on the past experiment that happened 9 out of 15 times, simplify that to the fraction 3 over 5, so that probability is 3 out of 5, or if you wrote it as a decimal, it would be 0.6, or as a percentage, 60%. And then part 2 of that, that should have said what is the probability that there won't be 50 or more people on the 15th day. So this is showing a complementary event. Either they're going to be there or they're not going to be there. So the difference would be 2 out of 5, which would be 0.4, which would be 40%, because an event and its complement add up to 1 or 100%.